Okay, so we're good on number 3. That was 3B. Okay, so clearing this out, going to number 4. Okay, I'll take questions on number 4 now.
You do B.
4B. Can definitely do 4B. Let's look at 4B. Okay, so determine the absolute minimum on the closed interval. Okay, so the minimum has to occur either at the endpoint or the critical point. So the critical point would be, it looks like it's at 6. Because right here, it's going from a negative to a positive. We're talking about the derivative. So my only critical point would be at, let's see, is it t or x? Looks like it's x. So I'm going to, for 4B, I'm going to test the candidates. So we have x, and then f of x. So the 4 candidates are going to be 0, 6, and 8. That scribble is really annoying me, but I have no idea how to get rid of it. Let me look for one more thing here. Yeah, I have a different set of, if I do annotate. Maybe I figured it out here. Yay! Okay. Everything is in a different place now when I'm using a new device. Okay. So I have to get familiar with this. All right, so that's exciting. So coming back here. So 0, 6, and 8. So the function, it's going to be the starting value plus the net change. Well, f of 8, we already know. That's going to be our starting value. So right here, it says f of 8 equals 4. So we don't have to do anything for that one. So those are my endpoints, 0 and 8. Okay, if you want to find f of 0, so f of 0, where can I fit that? So do it up here. F of 0 is going to equal, it's going to be the starting value. This time we're actually starting on the right and going from right to left. So my starting value is going to be f of 8. My net change is going to be the integral. We're starting at 8, so that goes at the bottom, and then we're going to finish at 0. So we're working backwards. We're going from right to left. We're starting on the right, and we're getting back to the point on the left where x equals 0. So, and we're given the derivative graph, so it's going to be f prime of x. So this is going to equal, f of 8 we know is 4. Okay, then plus, if you want to find the integral from 0 to 8, or from 8 to 0, this is going to be 7 minus 3 plus 6 plus 2. So 7 minus 3 because it's under the x-axis, so 7 minus 3 is 4. 4 plus 6 is 10. 10 plus 2 is 12. Because you're going from right to left, you take the opposite of that number. So it's going to give you an area of negative 12. So this is going to give you negative 8 here. So f of 0 is going to be negative 8. Okay, now I want to find f of 6. It's still going to be the starting value, which the known value here that we're starting at is f of 8, plus the net change. So the net change is going to be the integral from 8, and we're stopping at 6. It's going to be f prime of x. So f of 8 is still 4. If you go from 6 to 8, or from 8 to 6. It has an area of 7, but we're going to make it negative because we're going from right to left. So 4 minus 7, which is negative 3. So going back to the question is saying, what is the absolute minimum? So we look for the lowest value and then justify our answer. So the answer is going, oops, it's not going to be negative 3. It's actually negative 8. Usually it's a critical point, but not here. So of all three of these numbers under f of x, negative 8 is the smallest. So I would say f of 0 equals negative 8. And this would be my absolute min here, because it's the smallest of the three candidates.
Can you explain one more time where you got negative 12, Mr. Morrison?
Negative 12, yes. So to get negative 12, I'm finding this integral right here. So that means I am doing this area minus this area because 3 is under the x-axis. So 7 minus 3 plus 6 plus 2 because they're all above the x-axis. So it's going to be 7 minus 3 plus 6 plus 2. And that's going to give me positive 12.
Mm-hmm.
But the reason it's negative 12 is because we're going from right to left. We're going from 8 back to 0. So the direction we're moving in is going this way on the graph. So you take the, at the end, you take the opposite of that number.
Okay, thank you.
So going from x equals 8 back to x equals 0. Anything else on number 4?
Mr. Morrison?
Yeah.
So on that part, when it says justify your answer, or when it says justify your answer, that's all you need, right? You don't need any more sentences or anything.
As long as you say test the candidates and you show you show these answers, that would work. That's absolutely enough to justify your answer. You're considering all three candidates and you're finding the candidate with the smallest y coordinate.
Okay, thank you.
How come you have to go, like when you did the negative 12, why did you go backwards? What was the reason?
Because see how 8 here is at the bottom? That's where we're starting. We're starting at 8. You always start at the bottom number and you finish at the top number. So we're starting at 8 and we're finishing at 0. So this is why f of 8 here is our starting value. So that always represents the lower limit of integration, the starting value. So you're starting at 8, finishing at 0. So going from x equals 8 to x equals 0, you have to go from right to left.
Are you only starting there because that's the condition it gave you?
For every integral, you always start at the bottom number. So just a reminder, so if you have the integral from 0 or from 8 to 0, that's going to equal the opposite of the integral from 0 to 8. So whenever the bigger number is at the bottom, you always take the opposite of the integral. Because that means you're going from right to left when the bigger number is at the bottom. It's okay?
Yeah.
Okay. All right, other questions? Okay, I'm going to clear this out. We're going to go to number 5. I have all these like habits I'm used to doing, and then I realized I was having some issues earlier. Okay, so I'm using a new device now for moving through the problems. So thank you for being patient. Okay, so questions on number 5.
Can you do A?
A, yes. Let's look at A. Let me make this a little bigger. Okay, so letter A. So 5A. Let's see, f of x was x approaches 0. So f of 0 equals -1. So I could say the limit as x approaches 0 of f of x plus 1 this must equal 0. And then I could say the limit as x approaches 0 of my denominator, which is sine x, that also equals 0 when you plug 0 in. So we have a 0 over 0 situation. So we can use L'Hopital's rule if the limit of the numerator and the denominator both equal 0. So that means this limit here, maybe I'll come up here, the limit as x approaches 0 of f of x plus 1 over sine x must equal the limit as x approaches 0. You take the derivative of the numerator, which is just f prime of x, and you take the derivative of the denominator, which is cosine x. So this is going to equal the limit, actually backtrack, undo. So here, this is going to be f prime of 0, since I can already tell this isn't, I know cosine of 0 is 1, so I can't do L'Hopital's rule again. And then over cosine of 0. So this is going to equal, when you figure out f prime of 0, do a little scratch work here, f prime of 0 is going to equal, I'm going to use this right here. So it's going to be y squared times 2 times, we know x is 0, plus 2. We just have to figure out what y is when x is 0. So when x is 0, we have here, we know that y, actually we know y. So y, it tells us, is -1. So this is going to equal 1 times 2, which is 2. So I'll plug that in here. So this is going to be 2 over 1. So my answer is 2. That's okay for 5A.
Yep.
Okay.
Can you do 5D? I mean C.
5B. Say that again. 5 what?
5C.
5C. Okay, let's look at 5C. So I'm going to clear this out. Okay, so 5C. If you want to solve a differential equation, you want to separate the variables and take the integral of both sides. So I'm going to do dy over, I'm going to divide both sides by y squared, and then I'm going to times both sides by dx. So now that I've separated the variables, all the y's on one side, all the x's on the other, I'm going to take the integral of both sides. So on the left side, think of this as y to the -2. You take the integral of y to the -2. That's going to be -1 over, that's going to be negative y to the -1, or you could write it as -1 over y, equals, you take the integral of the right side, it's going to be x squared plus 2x. Don't forget your plus c. Okay, and then from here, I have to get y by itself. So do we have an initial condition? We do. So f of 0 equals -1. So that means I'm going to plug in -1 for my y and solve for c. So y is -1 when x is 0. So when you solve this equation, you're going to get c equals Oh, wait, it's -1 divided by -1. So which is just 1. So C equals 1. So I'm going to take this, plug it back in here. So now I can rewrite my equation as -1 over y equals x squared plus 2x plus 1. And then to solve for y, just switch y with whatever's on the other side. So y is going to equal -1 stays on top, and then on the bottom it's x squared plus 2x plus 1. And this would be your solution to the differential equation at the given initial condition, f of 0 equals -1. So anything else on number 5? Okay, clearing this screen, going to the last one here, number 6. I can't get used to scrolling. I'm so used to sliding. Okay, so number 6. I think I had you do all of number 6 on this one, if I remember correctly. Okay, so number 6, questions on this one here.
6C.
6C, let's look at 6C. I think there's a very good chance you're going to see a Taylor polynomial on the AP test. Not Taylor series. You guys know the difference again between series and polynomial. Series means it goes on forever. A polynomial stops at a certain term. Okay, so for 6C, it's asking us to find h prime of x, which we know is f of 2x, or we want to find h prime of 0. Let's first start with this. So what do we know here? We have to use your answer for part B, I think, for this one, if you wanted to find the third order polynomial. Is it that one? Let's see. It's hard starting at C sometimes. So I don't know that I have the information I need here. So let's backtrack. Okay, so I think on part B, it's asking for the third order polynomial. So I'll go back to B for a second. So the third order polynomial is going to equal, it's -4 plus 2x using this, and then we know the first derivative is 2, so then I just times that by x. Okay, then it's going to be, what do we have for the second derivative? It's -2/3 over 2 factorial, and then we have x squared since we're centered at 0, and then we have -2/3 and we have 1/3 for the third derivative. So that's going to be over 3 factorial times x cubed. So this is going to be -4 plus, if we're doing f of 2x, this is our approximation for f of x. So instead of x, I'm going to substitute our 2x, which is inside the parentheses. When you simplify -2/3 over 2 factorial, that becomes -1/3. And then you have 2x squared. It says find the third degree. Okay. So eventually I'm going to have to integrate this. It should say squared here. I'll just go to the next one. So it's going to be plus 1/3 divided by 3 factorial. 1/3 divided by 6 is 1/3 times 1/6, which is 1 over 18. And then 2x cubed. if it says find the third degree Taylor polynomial for h, I have to take the integral of this. So I'm going to take, to get from h prime of x to h, you have to take the integral. So that means I'm also going to take the integral of all of this. So this is going to give me h of x equals, when I integrate -4, that's going to be -4x. And then this right here becomes 4x. When you integrate that, that's going to be 2x squared. When you integrate this term, that's going to be -1/3 4x squared. So when you integrate that, that's going to be -4/9 x cubed. I don't have to keep going because I already have a cubic. I do need a plus c though, because I just took the integral of a polynomial. Okay, so now all I have to do is solve for c. So to solve for c, I'm going to use the fact that h of 0 equals 7. So I'm going to plug in for h of x, so -4 times 0 plus 2 times 0 squared minus 4/9 times 0 cubed plus c. When you solve this for c, you're going to get c equals 7. I'm going to plug that in here and then go to my answer. So my final answer, if I can fit it somewhere here. My final answer is going to be h of x equals -4x plus 2x squared minus 4/9 x cubed plus 7. To me, this looks like a really good candidate for a type of problem you might see, because it ties in like Taylor series with integration, or Taylor polynomial with integration. So this definitely would be a good one to go over again before next week. Can't believe 1 week from today, 11, actually 1 week from this minute, the AP test starts. Is that crazy? 1 week from this very minute. And you also want to get there, actually you want to get there like half an hour early to start filling out the verification information. So the worst thing you can do is go on right before 11 o'clock. You're not going to have enough time to complete everything you need. So there is a process to verify your identity. So make sure you start like around 10:30 a.m. on Tuesday. I don't know if this is your first AP test, but I don't want this to be used as a learning experience. I want the learning experience to happen before the AP test. If you know what's expected for you, that's less you'll have to worry about the day of the AP test. You'll be able to focus on calculus and not all the other stuff going on. So make sure you get there 10:30 a.m. Using your e-ticket, which shows up 2 days before. So that would be on May 9th. You should get an email with an e-ticket. All right, so other questions, either AP test or number 6.
Why did you cross out the last term?
I don't, oh, or because if I took the integral of the last term, that would give me an exponent of 4. And the direction said 3rd degree. So once I got to my 3rd degree, I didn't need that last term anymore because I don't need an exponent of 4 taking the integral.
Okay.
Okay.
Can you do letter A, please?
Letter A, let's look at letter A. Okay, letter A, let me clear this out. So 6A. So we're trying to find, show that f prime of 0 equals 2. So that means it's a first order polynomial if we're only going to the first derivative. So for this one here, I'm going to say P1 of x is going to equal, we have our constant, which is -4. You don't have to write over 0 factorial, but I like to put that just to clearly see the pattern. And it's x minus c. Again, you don't have to say minus 0. plus, then your first derivative, which is f prime of 0. We don't know that just yet, but we're showing that it's going to equal 2. So over 1 factorial, x minus 0 to the 1. So when I simplify this, it's going to give me negative 4 plus f prime of 0 times x. And we know that when x is 1/2, the first order polynomial is negative 3. So I'm going to substitute negative 3 when x is 1/2. So I'm going to add 4 to both sides. So that gives me 1 equals f prime of 0 times 1/2. And then to get f prime of 0 by itself, I just multiply both sides by 2. So f prime of 0 will equal 2. And this would be another good problem, because I'm just thinking problems where it makes it hard to cheat are going to be popular problems that they're going to want to pick, because showing something isn't just finding an answer. It requires students to have to do work. So 6A would be, again, just trying to think like the writers of the test. They're probably not going to give you problems where you could just call a friend and be like, what's the answer for number 6A or something. So something like this would probably be a good one, because you have to show all of your steps here. And again, don't stress if you're not able to finish. That was clearly communicated to AP teachers, that it's not expected that you finish every single problem. So and it's okay to skip problems, but don't try to rush through problems just to finish everything. It's better that you get the ones right that you're doing. Make sure, reread the question, make sure you answered it completely. A lot of time, it's a point just for like quick justification or quick explanation. Explain means use words, justify is use math. So if you see the word justify, like test candidates or something, you're using math to justify. Explain would be writing a sentence for the reason.
Mr. Morrison,
Yes.
how come you said it equal to the P1 of X?
Just because if it's giving me, that's what it's giving me here. It says P1 of 1/2. So that means we're working with the first order polynomial. So we're going up to the first derivative. So I'm just using the given information on 6A. It tells me that I'm only going to the first derivative, which means I'm working with the first order polynomial, first order Taylor polynomial. So the order tells you how many derivatives you take. Go ahead.
Isn't that at 1/2 though, not 0?
Well, 1/2 is just the x coordinate that we're plugging in right here. So I'm just plugging in 1/2 for x. The 1 down here tells me that it's piece of 1. That tells me I'm going all the way to the first derivative. You don't have to go past the first derivative.
Oh, okay.
Okay, other questions on 2013? Okay, I'll give you a couple minutes. I'm going to start 2012 in a second. If you need to stretch or go to the bathroom or something, I'll stick around if you have general questions as I try to get 2012 good to go. So this is a good time if you just have any general questions about the AP test or the extra credit coming up. So that's going to be due Thursday night, the extra credit. So that'll be, other than the Zoom session Friday, that'll most likely be the last extra credit of the year. And then by Friday, you should know your semester grade. Okay, so I'll take questions now as I try to transition over to 2012. So I play with the settings here to know where everything is. There's 60 people here. That's amazing. Sorry, and this was the lesson I botched when I had my highest turnout. I have to figure that out. My iPad wasn't connecting to Google Drive for some reason.
Mr. Marson,
Yes.
are you gonna do like a review session the day before the test or no?
Well, Friday is our last scheduled Zoom session. I could, I could, I guess. I'm trying to think. I just don't know if that would like overlap with stuff you have in other classes.
I'm not you have to. I was just asking if you were. I don't know. It's not a big deal.
Maybe we can see how Friday goes and then decide. Yeah, we'll see what we can get through Friday, and then we can kind of figure that out. Make sure this is just for everybody. Make sure you're going through your yellow book too, because the yellow book there's that section in the yellow book that says when you see this, do this. I'll probably send that to you on the next Google Classroom post. But over the last couple of years, I've heard several students just say that saved them on the AP test, because it's really focusing on what to do first step. I'm realizing the more years I do this, the more they're really emphasizing what to do first. So that I think like the true false questions on the link I sent you yesterday, that's also addressing that, what to do first step. So that should be a big part of your focus as you're doing like last minute review, is what to do first step, because you can often, especially on free response questions, you can often get points just for knowing what to do right at the beginning of the problem. Let me see. So we talked about AP Classroom, we talked about the extra credit, the links. If you don't finish, that's okay. We talked about the e-ticket. You talked about getting there 30 minutes early. We talked about, you guys are okay. One of the links is about practicing submitting your response. If you're taking a screenshot on an iPad, that should be fine. iPad might actually be the best way to go if you have or some kind of tablet, because the advantage of the iPad is it's a big screen and it can take pictures. I'd be nervous to just do it on a phone if it's such a small screen that you're looking at. I am pretty sure you can send it from one device to another, but every second is going to be valuable for you, because if you don't submit it by the time it tells you to, it's going to give you a 0 for that question. So it's better to have an extra minute or so in terms of time that you could have been working, rather than to risk not being able to submit the question before the timer goes out, because there's going to be a timer the entire problem, and it'll turn red when you have 5 minutes left. That's when you should start uploading. Okay, so any other questions before we start number 1 on 2014? Okay, so hopefully we're feeling okay. Again, I'm really prioritizing I don't want you to get bogged down by all this extra stuff in terms of submitting photos and things like that. I want you to be able to focus on calculus and know as best you can what's expected of you on May 12th. All right, so number 1, 2012. I'll take questions here.
Letter D.
D, let's look at D. Okay, so on 1D, we want to find the temperature. So it's giving you the formula for the rate of change and asking about the temperature. So that means I just want to find W of T. So the formula is going to be the starting value plus the net change. So the starting value, if we're going from 20 to 25, we're starting at T equals 25. I'm sorry, starting at T equals 20. So at T equals 20, the temperature is 71 degrees. So it's going to be the starting value plus the net change. So the net change is going to go from 20 to 25. So I could actually change this T to, since we're doing it for 25, I'm going to change the T to a 25. If you want to write this on the next step, that's fine too. And then we're going to undo our derivative formula right here. You don't have to write it out. You could just say W prime of T if it's defined as a function. And then even though a calculator shouldn't be required on the AP test, you would just plug this into your calculator, substituting W prime of T. You would, on your calculator, do 0.4 square root of x times cosine of 0.06x. And that'll give you the answer, which to 3 decimal places is 73.043. I believe it's degrees. Is that Fahrenheit? Yep. So that would be the temperature at the 25th minute, knowing the temperature at the 20th minute.
Wait, so when would you use this formula?
You mean the starting value plus net change?
Yeah.
Anytime you know, like here we know, if it gives you an interval, that's a clue right there. So you're going from the 20th minute to the 25th minute. So in looking at the table, it gives you the temperature at the 20th minute. Then you have to integrate from the 20th minute to the 25th minute to find the net change. So just based on the circumstances, you have a starting value and you're able to find a net change. That's how you would find a new value, a final temperature after 5 minutes had passed from the 20th minute to the 25th minute. Is that okay?
Wait, so whenever they ask you for something at a specific time, that's when you'd use the formula?
It's based on if you know the right conditions. So like if you know a starting value, so you see for this one, we're starting at 20, and you know up here the temperature at 20 minutes. And then you have a change that's happening from minute 20 to minute 25. So it's when you have a starting value and you have a change happening over an interval. So under those conditions, you can find the new temperature at a new point in time. So at the 25-minute mark, the temperature would be about 73 degrees Fahrenheit. And you also have to be able to undo a derivative to get a net change. It's like when you undo velocity, it gives you a change in position over an interval. That's okay for 1D?
Yeah.
Okay. Other questions on number 1?
Can we look at 1B?
1B. Yep, let's look at 1B. Okay, so on 1B, here we're going from 0 to 20. So when you undo a derivative, it gets you back to the original function. So that's just W of T from 0 to 20. So this is an antiderivative. So I'm just going to plug in 20, and then I'm going to plug in 0, and then I'm going to subtract those values. So W of 20, according to our table, so the temperature at 20 minutes would be 71 degrees. And you're going to subtract the temperature at 0 minutes. So the starting temperature would be 55 degrees. So this tells you that the change in temperature over, or let's see, what are we finding here? The temperature, and then interpret the meaning. Okay. So this would be 16. So you have to, this is why it's important, rather than be in a rush and just go on to the next question. It only takes a few seconds to reread the question. So in this case, it's asking for more than just the change in temperature. So interpret the meaning of this. So what we just found here is I can say the water increased, I'm gonna have to abbreviate here because I'm running out of room, increased in temperature by 16 degrees Fahrenheit over the first 20 minutes. So that's what you're doing when you're undoing a rate of change over the course of an interval from like 0 to 20. You're finding a net change, how much the temperature changed over that interval, an accumulation. So is that okay for 1B?
Thank you.
Yeah. You don't have to worry about plus C when it's a definite integral. So I think you guys all remember that, but just to make sure, if you see numbers like 0 and 20, you don't have to worry about a plus C at the end. So that's only for an indefinite integral. So again, these are questions I could really see them focusing more on this year, just because for someone to explain their work, that's a harder thing for cheating to occur when you have to be able to write and using your own words. So anything else on number 1? Okay, clearing this out. And then scrolling down. See me scrolling. So number 2. Wait, yeah, we had to do 2 on this one, right? No, just kidding, we skipped 2. Okay, skipping 2. Yeah, 2012 was the last year we skipped 2. Okay. So coming down, questions on number 3. You guys saw the thing that Jacob sent or mentioned. You see how over the last like 10, 15 years, or I don't know, it goes back 10 years, but almost 10 years, you can see the same types of problems are used over and over again. Number 3 is always interpret a graph. So it's not going to be, just because there's not going to be 6 problems this year, it doesn't mean they're not going to use a lot of the same types of problems. So hopefully when doing enough of these, you get really good at them. So you'll be ready if or when you see them next Tuesday. Okay, going to number 4 then. Okay, I'll take questions on number 4.
A.
4A, yep, let's look at 4A. 4A here. Okay, so 4A. This is a learning experience for me using new settings. Okay, so 4A. So write an equation for the tangent line at x equals 1 and use this line to approximate f of 1.4. Okay, so you need a point and a slope to make a line. So we're focused on x equals 1. So at x equals 1, we know that f of 1 equals 15. So we have a point. So my point would be 115. And I need a slope. So at x equals 1, my slope, my derivative is 8. So now that I have a point and a slope, I can make the equation of a line. So using point slope form, it's y minus y1 equals my m times x minus x1. So if you want to leave it like this, that's fine. So this would be 1 point right here, just writing the equation for the tangent line. So y is going to be your f of x here. So you can also think of this as f of x equals 8 times x minus 1 if you want to add 15 to both sides. And then f of 1, or no, we're approximating for f of 1.4. So then I would just plug 1.4 in. And you could just leave your answer like this. 1.4 minus 1 plus 15. Please don't simplify arithmetic. Unless you can do it in your head faster and you're 100% confident in your answer. Just because, again, you lose the point if you make a mistake there. So just leave your answer like that. I know when you're checking your answers, it's always in simplified form, but I promise you that will give you full credit on the AP test. So just remember, seconds on your AP test matter because you're not going to have enough time, most likely, to finish all the problems. So anywhere you can save a few seconds, that's going to be valuable, whether that's in uploading your work, have a plan for that, whether that's getting there a half hour early, whether that's having your AP ID on top of all your papers at the beginning before you start. There's a lot of things you can do to maximize your time, and that's what calculus is about, optimization. So we're optimizing our seconds when we're taking the AP test next week. Okay, so other question, or that's okay for number 4? Okay, other questions here.
Can you do B?
Let's look at B. So I'm gonna clear this out. Okay, for part B, it says we're gonna do the integral from 1 to 1.4 using MRAM. I don't think there've been many MRAM problems. Okay, so let's look at this here. Okay, so on 4b, it's the integral from 1 to 1.4 of f prime of x dx. Because we're any rectangular approximation method, RAM is going to be an approximation. So I'm going to say approximately. To do MRAM, if you want to find 2 subintervals, that means you're going to go from 1 to 1.2. And then 1.2, so it's going to go, the first interval is going to go from 1 to 1.2. The second interval is going to go from 1.2 to 1.4. That would give you 2 subintervals. So for MRAM, you're looking at the midpoint of each interval. So the midpoint, right in the middle of 1 and 1.2, would be 1.1. So that means I'm going to focus on the y-coordinate at 1.1, and then right in between 1.2 and 1.4, that would have a midpoint of 1.3. So the y-coordinate at 1.3 would be 13. Those represent the heights of your rectangles. So one of your rectangles has a height of 10. The other rectangle has a height of 13. If you want to find the base, you just find the length of the length of the interval. So the base is going to be the distance. I should have said 1.2 there. Okay, so to find the base, if you want to find the base of the rectangle from 1 to 1.2, that has a length of 0.2. And then 1.2 to 1.4 also has a length of 0.2. So both of these are going to be 0.2. Just leave your answer like this. So this right here would give you full credit for your MRAM. Let's reread the problem. Then so there's a second part of the problem. That's why it's so important to go back and reread the question. Those are good uses of your seconds. Rereading the question is very, very important because it's easy to miss something. So use this approximation now to estimate the value of f of 1.4. Okay, so right here, I'm going to say f of 1.4. It's going to equal the starting value plus the net change. So the starting value it's giving us the starting, whatever it gives you is going to be the starting value. So it gives you f of 1. So it's going to be f of 1 plus the net change. So that's going to be from 1 to 1.4. The net change, you're taking the integral of the derivative every time. So this is going to equal, maybe I should say approximately. So f of 1, it tells you right here it's 15. Plus what we just found on part B represented our approximation. So it's going to be 10 times 0.2 plus 13 times 0.2. So you're just adding 15 to your answer from part A. And I've said before, if you have no idea how to do part A, just write an answer, write 2. And if you can add 2 to 15, you'll get full credit for part B. So even if your answer for part B requires you to know the answer for part A, as long as you use the answer correctly, you get credit. So don't just, the worst thing you can ever do is leave a problem blank unless you just have no clue absolutely no clue and you can't base it off of another answer. You don't want to leave blank work. You might get points just from writing chicken scratch once in a while. So I definitely advise you against leaving anything blank if you can avoid it. But at the same time, I don't want you to rush. So it's a balance. Don't go too fast. Don't go too slow. Try not to leave anything blank unless you absolutely have to. So have that plan going in. Like, know that you're going to be working at a good pace, not too fast, not too slow, just like the test we've been doing all year. So the strategy just seems so critical, especially this year with everything going on. All right, so other questions on number 4. Okay, let's go to number 5.
Actually, can you do C? Sorry.
C, no problem. Let's look at C. Okay, so on letter C, for Euler's method, I'm going to do it like this. And then for my third column, I'm going to do the change in x times the derivative. This is the same as y prime. Hopefully you can read that okay. dy over dx times is going to equal the change in y. So it should give you a starting value. So we're starting at x equals 1. And we're told right here that don't go off the table because the table gives you the derivative, not the y coordinate. So it gives you the rate of change is 8, but the y coordinate at x equals 1 is 15. And it says 2 steps. So if you're going in 2 steps to get to 1.4, you could just do 1.4 minus 1 divided by 2, which is 0.4 over 2. You could probably do this in your head without having to do this work. So I'm going in steps of 0.2. So add 1, then you have 1.2, and then 1.4. So we just took 2 steps from 1 to 1.2, 1.2 to 1.4, since we're trying to approximate f of 1.4. So you don't have to do this work if you can see it right away. To get from 1 to 1.4 in 2 steps, you go 1, 1.2, 1.4. But if you like a formula, you have a formula there. Subtract the numbers and divide by the number of steps. Okay, so that means delta x will always be 0.2 no matter what. So it's going to be 0.2 times dy over dx. So dy over dx, it should give you a formula somewhere for dy over dx, I hope. Oh, okay, wait. So at x equals 1, it actually doesn't give you a formula. Here it's even better. It just tells you at x equals 1, it says that right underneath that, the derivative is 8. So to find your change in y, it doesn't always give you the exact same situation. That's why knowing what to do in a certain situation is so important, first step. Okay, so 0.2 times 8 is 1.6. And that's why we do like 12 free response questions, because I want you to get experience with, basically it's the same problem every year, but they change the situation slightly. So you have to be able to be ready for that when they slightly change the given situation. Like here, instead of a formula, they give you a table. So be prepared for anything. So 1.6 is what I add to 15. So 15, you add it to 1.6, you get 16.6, and you repeat the process again. One more time, 0.2 So when x is 1.2, it gives you the derivative, which is 12. So I'm going to just times this by 12. That's going to be 2.4. 2.4 is the change in y. That's what you add to 16.6 and you're done. So 2.4 plus 16.6 is 19. So to write my final answer, I'm going to say f of 1.4 is approximately 19 using Euler's method. Using two different tangent lines to approximate it. So anything else on number 4?
Mr. Morrison, this is more of a general question.
Yes. Mm-hmm.
For 4D, when it asks you for the second degree Taylor polynomial, are you going to the third term for the second degree, or are you going until when your exponent is 2?
Yeah, good question. You are going to the third term because you're also including the constant. So you have like a naught is your constant plus a sub 1 x to the 1 plus 2x squared.
Okay.
So it would be, as long as none of the coefficients are 0, you don't have 0 in the numerator, second degree would also always be 3 terms.
Okay.
If you wrote it to the third term, would you get marked off on the AP test?
That's a good question. Usually I know the answer to that, but that I'm not sure. I wouldn't. That's a really good question. That's kind of mean if you did more work, but at the same time, it does ask for the second degree. I mean, I would definitely stop at the second degree to be safe. But yeah, I don't question.
Okay.
Yeah, I've done a lot of reading and talking to people, but that I've never heard the answer to that question. If it says second degree and you got everything right and went to the third degree, I don't know if they would dock the point. Again, I'd hope not, but I don't know for sure. Okay, so other questions on number 4?
Wait, so if it were to
Okay,
ask
good.
for this,
Hmm?
if it were to ask for the second degree, but like one of your terms were 0 before you got to the second degree, then would you continue till when your exponent is like 3 per se?
Well, if one of the, like, let's say this term had a numerator of 0, then you would just have 2 terms. You would still stop when you get to x squared. But I think your question earlier was, if it says second degree, will you always have 3 terms? And the answer is you'll usually have 3 terms, but the only exception would be is if one of the numerators, like over 1 factorial, like let's say there's a 0 on top, that would wipe out the term. That would not count as a term.
Okay.
So then you would only have 2 terms in your answer, but you'd always stop at x, the term with the x squared. Okay, so we're gonna go to number 5 here. So logistic growth. One of my posts previously, I said I wouldn't be surprised. I think this is actually the first one. There's another one in 2008, which you just turned in this morning, or you hopefully before this morning. But I wouldn't be surprised, even though it hasn't shown up in a while, I wouldn't be surprised if you saw logistic growth with everything going on in the world this year. So I'll take questions on number 5.
Letter B.
Letter B, let's look at letter B. Okay, so on letter B, find the second derivative in terms of B. Here, it doesn't really ask much specifically, or if anything, about logistic growth. Maybe the 2008 one did. But this is the same idea. This is a logistic growth graph. Even though if you didn't know that, you could still be okay here. Okay, so looking at this one, if you go, we're starting at b of 0 equals 20. To explain why b cannot resemble the following graph. Okay, so if b is between, starts off concave up and then it's concave down. You have an inflection point somewhere about right here where it changes concavity. So it looks like from 20 to 100, this graph, well, from here to here, it's concave up. So that means I can say the concavity is clearly changing on this graph. Based on the information we know here, if I was to take this and plug in any number for b, so let's actually find the second derivative here. So the second derivative, if you wanted, you could distribute the 1/5 if that's easier for you, but this is going to give you negative 1/5, or you do chain rule, you could do that too, times dB over dt, which is going to be negative 1/5. We know dB over dt, so I can substitute that in. So it's 1/5 times 100 minus b. So this is going to equal negative 1 over 25. There's different ways you could approach this problem, but when I'm looking at it, I see that if b is a number between 20 and 100, that means this right here will always be negative. So this will always be less than 0 when b is between 20 and 100. And then 20 and 100, those are asymptotes. So it's not actually going to equal 20 over 100. So you have like a horizontal asymptote at 20 and then a horizontal asymptote at 100 for logistic growth. So you can plug in any number into this for b between 20 and 100. So 100 minus a number between 20 and 100 will always be positive. When you times that by negative 1 over 25, it'll always be negative. But this graph, you can see it's not always has a negative, it's not always concave down. So according to this should always be concave down. So concave down over the entire interval. On this graph, you can see that it changes concavity here. Did say graph changes concavity for b being between 20 and 100. This could not represent the graph of the function, or this could not, yeah, this could not be the, or this could not be the graph to model the differential equation.
Can you just say that B is concave down? Would that be enough to justify?
As long, if you say b is concave down, but you have to specify over the interval from, the interval is along the y-axis here. So if this is your b-axis, so where b, if you'd have to specify over the interval from 20 to 100, it would be concave down. So you'd need to say a little, you might get like, maybe it would be out of 2 points, you'd probably get 1 point for talking about the concavity, but maybe not the full credit for that.
Okay, thank you.
Mm-hmm. So these two things are contradictory. So this graph is not consistent with the work on the right. So the work on the right says it has to be concave down everywhere, but the graph we're given is not concave down over the interval along the vertical axis. Normally intervals go along the horizontal axis, but here we're doing an interval along the vertical axis. Okay, other questions on this one?
Mr. Morrison, for 5b,
Yes.
instead of talking about the concavity, could you talk about the first derivative, how it's like increasing at a decreasing rate, or is that not enough to justify?
If you say it's increasing at a decreasing rate, so there's two ways it can increase at a decreasing rate. It could go, actually, no, there's only one. So this would be increasing at a decreasing rate. That's fine. That's the same as talking about concavity.
Right.
So that's, yeah, if you said this graph has to be increasing at a decreasing rate, that's one way to describe what's happening. So that would work.
Okay.
But there's two ways to be concave down, just so you know. But what you said is okay. It could be increasing at a decreasing rate, or it could be decreasing at an increasing rate. Is that right? Decreasing.
Oh, yeah.
So these
like,
are two different ways that could be concave down. That what you said was fine though. But
okay.
just know that there's two different ways to describe downward concavity.
Mhm.
So yeah, that's a good point Tammy brought up. So it is important to know that as long as you can justify it, don't feel like you have to do the same thing that's in the solution guide. The graders are well trained and prepared to handle a lot of different explanations. Just make sure you're using correct mathematical explanations. There's different ways often that you can approach a problem. So yeah, don't get bogged down or think, oh, maybe because I didn't do it one way that I'm not going to get credit. So yeah, just know that so a lot of things are working in your favor. The fact that you only need 60% of the points, maybe even less. If they realize it's a really hard test, they could actually lower the bar in terms of what a 5 is. But usually it's 60% of the points. So on the final, which was, again, I apologize, but harder than I thought. I kind of realized it more after the fact. I knew it was going to be hard, but I didn't think it would be as hard as it was. But it was, yeah, if you get 60% of the points on the final, it was at least 14 out of 23. That would have been a 5. But I think it was 8 or 9 points you needed to get a 3. 9 points out of 23. And you can get 9 points, like I said earlier, just from knowing that yellow book really well can get you 9 points. So 9 points should not be difficult if you are prepared. If you're not prepared, that's a different story. So that's why it's so important that you finish this week strong. I know you guys have been through a lot, but yeah, I don't want you to look back and be like, oh, I know I was bummed, everything going on, and I could have taken it more seriously. So, and I don't want the final to discourage you either, because I anticipate the AP test not being that difficult. So let's hope for the best, but just know there are going to be problems you're going to see that you're not going to know how to do. That's expected. Just focus on the ones you do know how to do. That's where you should spend the majority of your time. Okay, so anything else on number 5? Okay, I'm going to look at number 6. Then we'll wrap it up with that. I think for the extra credits already posted on Google Classroom, I'll probably just have you take a picture of just any math work you have in front of you. It could be 2013, 2012 AP test. It could be notes you've taken. Any math work you've done is fine. But that's going to be that's due in, I think, about 15 minutes. So no hurry on that, but I want to make sure you'll have time to do that. Okay, so questions on number 6. Did everyone just leave to do the extra credit? Maybe I should have waited. Everyone's so focused on the extra credit now, I think.
Can you say it again, the extra credit?
Yeah, so the extra credit, just take a picture of any math work that you've done. It could be any of the free response questions, 2012, 2013, just any page of any math. It doesn't matter. Not a big deal as long as there's some math work that you've written out.
For number 6, Mr. Morrison, did we have to do 6b?
I think I had you skip one. I had it here. I looked at it before and I forgot now. Let me see. 6b. Let me see. I've actually been better about looking at which ones were skipped. I remembered there was one where it was only number 2 that was skipped, but I think for this one, let me see. So this is 2012, 6B, yes. So 6B is skipped.
Okay. Then can we look at 6c?
Let's look at 6C. Okay. Here. Hold on 1 second. Okay, so 6C. So this is write the first 3 terms and the general term for the Maclaurin series. So I don't think they're going to ask you anything about a general term, but if you find the first 3 terms, that makes it a Taylor polynomial. So that's why I still assign C, because this is still good practice. So on 6C, here. So this is going to be G prime. Do we have G prime of X? Okay, so we have the formula up here. So I'm going to focus on the first 3 terms, and I'm going to take the derivative. So for the derivative of the first term, it's just 1/3. And then the next one, I bring the 3 to the front and subtract 1 from the exponent. I don't think I'm going to worry about the general term just because that has to do with the series. So I'm just going to focus on these first 3 terms. And actually, that's all you have to do for the derivative. So they wouldn't ask you to do anything on the AP test beyond finding the derivative of a Taylor polynomial. So that's nice. You don't have to worry about finding the general term because that goes with the series. So I want to make sure that's clear to everyone because it's a little confusing. I'm kind of surprised they did that, but they're including Taylor polynomials, but they're not including Taylor series. So Taylor series is the general term of a series that goes on forever. You don't have the ... anymore. So is that okay for 6C?
Yep.
Okay. All right, other questions on number 6?
Wait, so Mr. Morrison, just to clarify,
Yeah.
we don't have to know general term at all?
No, you shouldn't, because that goes with the series. So if you see something about a general term, that shouldn't be included on the AP test. They specifically said you have to know Taylor polynomials, but you're not expected to know Taylor series, and the general term goes with the series.
Oh, okay.
So I'm always a little hesitant about saying things, but I'm pretty confident you shouldn't have to. I'm like 99% confident I don't know how they would, that shouldn't be on there. So this would be right here, this would be a 4th order Taylor polynomial for the derivative. Or actually, this would be the derivative of a 5th order Taylor polynomial, which is up here.
Okay.
It's also the 6th order, since the degree 6 would have a numerator of 0. Every even exponent has a numerator 0 when you're using the formula.
Okay. I don't know if you would know this, but for 6C, for instance, where it's asking for the first 3 non-zero terms and in this scenario, the general term, would it be a 2-point problem where like you would get 1 point for the 3 non-zero terms and another point for the general term?
Yeah, it would be 2 points. Every problem is at least 2 points. You might get like 1 point for getting the first term and then 1 point for getting all of them. That's usually what they do. But yeah, every problem, there could be a few exceptions, but almost every problem is at least 2 points.
Okay, sounds good.
Yes.
Are we gonna go over the final or no?
Do you got solutions that I sent you?